It's fantastic. We've had a very, very exciting few days launching our company, telling our story, and we talked to an awful lot of customers, a lot of partners, and of course our OEM partners as well. And the HPD Discover event is going on at the moment, which we've been highly active with. So thank you again to you and A3 Communications and the team. Do appreciate it. So I'm really going to just be introducing everybody. We have a number of the Nebulon executive team here today to take you through what we're up to. Speaking specifically today, Andy Roberts, who's one of our solution architects, he's going to be running through a demo. So I've got a live demo that we're going to be showing you as well, so you can see in some detail what we're up to. Going through all the technology overview is Martin Cooper. Martin leads our solution architect group worldwide. And the star of the show is Seamak Nazari, who I'm going to hand over to in a minute. Seamak is our founder, our CEO, and the guy with the genesis for the idea for Nebulon and our technology. And so I think it's always great to be able to hear from the guy that thought up the whole thing, and he's going to talk to you in a minute. Also, we have on the call Craig Nunez, who's our founder and COO. We're going to go for about 90 minutes. That's pretty much the running order, and then we're going to be wrapping up. I think there's an awful lot of questions already, so keep them coming. And we've got everyone here that can answer your questions as we go through it. So without any further ado, I'll hand over to Seamak.
Good afternoon, everyone. It's great to have everybody here. I think Tim did a fantastic job of introducing everyone. So let's talk about what we are up to. So the company is primarily founded by ex-3PAR alumni, David Scott, who was our CEO, and post-acquisition was the HP storage SVP and GM, is our executive chairman. I was the chief software architect at 3PAR and an HPE fellow. This company is really a combination of a lot of ideas that was conversations I was having with a lot of folks. I'm the CEO. Sean, who's our CTO, was the platform architect at 3PAR, and Craig Nunez is our COO, and he was our 3PAR CMO, and has had a couple of other stints at startups before joining us and co-founding the company with me. We have offices. We are actually, the headquarters is located in Silicon Valley, California. We have offices in Seattle, Belfast, Northern Ireland, and we have a commercial sales office in London. We've filed a number of patents up to now, but more than 10. We have folks from Snap that lead our cloud. We have folks from 3PAR that lead our storage engineering team. So this is really exciting. The company was founded in 2018, and we are off to the races. Next. So why are we doing this? And really, sometimes people come up with ideas looking for a solution. This was really a problem statement that I ran into, and the most succinct version of the problem statement came from a CIO that I was talking to 3-4 years ago. And the pain point he described was something along the line of, look, I'm buying storage arrays, they're expensive, they're multiple tiers that I have to set up, switches, yet I'm buying all these servers, and every single one of these servers that I buy have a disk slot right in front of them. Why do you make me buy these additional expensive services and equipment? Why can't I just use these sea of storage slots that I already have in my servers? And the answer to me was obvious at the time. If I have to use those, then have to put some sort of software on your servers, and you will hate me for it, because then that piece of software will interact with your operating system, and there are compatibility issues. But the statement of the problem and his need really stuck with me, especially the need to be able to manage at scale and use a much more simplified model. And the way you think about this, really the needs were, he wanted to increase his asset utilization by reducing the costs and the infrastructure footprint. He wanted to really increase his operational simplicity and agility by reducing the operational overhead that then accelerates the ability to deploy new services. And then what he didn't really specify, but you really wanted to do, and now you could do, is take the advantage of the cloud innovation across the enterprise, uh, essentially by giving the application owners a self-service on-premise experience. So, and I think what we did, we actually put up a survey asking questions around the CIO challenge, and I think it would be good to see if folks have had a chance to react to that. So, the solution to this problem is what we call cloud-defined storage. This is really the best way to describe it. On-premises server-based enterprise class of storage, but it doesn't consume any of the server CPU and memory resources. We define it and manage it all through the cloud. At its heart, it's really made up of two components. We have a secure AI-driven cloud-based control plane, which we call Nebulon on. And this Nebulon on cloud control plane, think of the Meraki networks where they had a remote cloud-based management plane, and then it controls some endpoint devices. In our case, the endpoint device is a PCIe-based services processing engine. We call it an SPU, or services processing unit. It is installed in the servers, and it essentially replaces the RAID or fiber channel cards that you would ordinarily expect to see in a server. The entire solution ends up costing about half the cost of what an expensive enterprise storage array will cost you. It is primarily because you're leveraging commercial, less costly server SSDs that are shipped by the server vendors, essentially by the millions, as opposed to specialty SSDs that the storage vendors are shipping in their servers. Next.
But consuming no CPU and no memory, so there's nothing running locally on the machine, nothing at all.
We'll get, well, it is something running. That's the PCI card that we talked about, but all of the storage functionality runs on that card. So literally, there is nothing running on the server other than the standard driver that comes with all operating systems.
So effectively, you're building a storage server onto a card and then putting that in the server.
You got it. The best way to think about it is we're literally taking a storage array and miniaturizing it to a size of a sizable PCIe card, kind of like a big GPU, and installing it on the server. Exactly. So the ideal customers for us are infrastructure managers and application owners, and there's a bit of a friction between those two entities in the data centers today, right? Application owners want to get going fast, yet infrastructure managers need to be careful. So there is a bit of a friction between those two. In this model, these folks need low latency mission critical workloads on their premises. They have tried software-defined storage or hyperconverged, but because of service level agreements or workload restrictions that come with software-defined storage, they're going back to external storage arrays. These folks tend to manage tens, hundreds, thousands of servers. These are massive scale enterprises often, and often they have multiple sites or edge locations. So the management becomes a pain point for these customers. Some of the example customers we've talked to, and this message resonates really well with these folks, is cloud services providers. They're looking for new cost-effective ways to deliver value to their clients. Mid to large enterprises, they're under a lot of pressure to reduce costs and offload the overhead on operations staff. In fact, one of the other challenges these enterprise customers have is that often their own users are going to the cloud and seeing kind of the ease of use and the API nature of the cloud, and they're demanding the same in their own enterprise IT staff. Next. So, the model of trying to sell a PCIe card and then the customer installing it on the server is just not going to ever take off. So the idea is to go to market using existing server vendors. So in this model, the server vendor will offer the cloud-defined storage, and the partners that we're going out initially to market with are Hewlett Packard Enterprise and Supermicro, and we have one other major server vendor, a third one, that we will be announcing shortly. The SPU itself and the subscription is all available as server options SKUs from each partner. So instead of buying a standard fiber channel card or a RAID card, the customer in the order process just orders one of our SPUs. All the quotations and order fulfillment is provided by the server vendor. And all the support agreements also go through the server vendor. And the same way that the customers are asking for fewer components in their data center, they're also asking for fewer vendors to deal with. And this allows the customer to essentially not deal with us as a vendor and just buys it from the server OEMs. They have contractual agreements, service agreements, all those things just go through the existing agreements that the customers have with the OEMs. Next. So a little bit about the technology, I think. Go ahead.
Sorry,
Yes.
C-Mac, can I stop you there? We have a question from
Absolutely.
Anthony. Unless, Anthony, you want to ask the question out loud?
I can do. It looks what you're proposing looks to me like software-defined storage to a large extent. And I'm just wondering what the advantage of putting the intelligence in the cloud is, or the intelligence, the controller functionality being distributed. If that's what it is, it looks like what it is to me. And I'm just wondering what the advantage of having things that way is.
I think that's a great question, and I think let's see. I think some of that question will be answered in Martin Cooper's presentation, because he will do a deep dive on the technology, both on the I/O path and on control plane. I think some of that becomes obvious once we go through the technology overview.
Okay. CMAC, one more question from analyst Tony Locke. What happens if cloud access is lost?
That's a great question. Essentially, the cloud. The best way to think about the cloud is means of, but if you think about software-defined networking, a network topology is defined and then is pushed into the switches. And from then on, the switch essentially operates, autonomously, right? It can even detect path failures and work around path failures. We kind of think of it the same way. So in the cloud, you define what the topology of the storage should be. You push it out into the SPUs, and then from then on, they're operating autonomously, including dealing with failure scenarios, drive failures, card failures. So in case of a disconnect from the cloud, the operations will continue unheeded because the capacity is sitting inside the data center. The transactions are happening in the data center.
Presumably,
you're acting as a controller cache. Then your card's acting as a controller cache.
That's correct. The controllers are caching the metadata of how they should be operating. Absolutely.
So as long as you don't want to actually change the topology, you can carry on going. But presumably, you'd need the cloud resource if you wanted to make changes.
That's correct, but we'll talk about how what we are defining is done at an application level, and the typical change cycle that you would expect from shared storage doesn't exist in this model. It's much more reduced interaction model.
And if I could, this is Craig, just going back to Anthony's question so everybody kind of understands. All the data services actually run on the card, not in the cloud. What's in the cloud is the control plane, all of the management, and the immediate benefit of getting those data services off the general purpose CPU and memory is number one, you don't have ties to the operating environment, so there's no restriction with what kind of OS or hypervisor you can deploy. Number two, customer gets to use all of their server for their application or VMs instead of giving up 20 or 30% of it to run IO services. The benefit of the control plane in the cloud, the team's going to get to, but you can imagine it has to do with scale and automation and that kind of thing. But I'll leave it at that and let the team carry on.
Okay.
Just out of curiosity, which cloud are we talking about, given that there is no such thing as the cloud?
Yeah. The cloud, the Nebulon On runs in a combination of AWS and GCP.
Geographically distributed?
Indeed.
So firstly, the SPU replaces the storage controller, and it connects to the host server in the same way that a RAID card does. It's a full length, full height, double width PCIe card, fits into a GPU slot and consumes quite a bit less power than a GPU. So any 2U 24 drive server that's GPU capable is on paper Nebulon capable. The SSDs are like a RAID card connected directly to the SPU. So we take over running those drives. So in the example of an HPE server, the SAS expander card plugs into the back of our card, and we take over ownership of the drives from there on in. We appear to the local host as simply as a SAS HBA. And this was really important to us, and one of CMAC's prime architectural visions, if you like, is that the insertion of the Nebulon solution into a customer's environment must be as frictionless, painless, simple as possible. And one really good way of doing that is not adding any third-party software or for a customer to have to install onto either their server or their hypervisor or their bare metal OS that kind of runs inside what they do. And if you think about that, again, the opportunity that brings us is we're also not pinned to being a hypervisor only solution. So we can run in bare metal as well and as easily as we can in any of the hypervisor solutions, because we present ourselves to a host in such a kind of simple manner. We'll see when we get to the live demo, which is towards the end of what I'm doing, and we're going to do two sort of flavors of that. But you'll see when we get to the live sort of demo, we have the option to install a boot volume and an operating system inside that boot volume, or a hypervisor inside that boot volume too. So again, sort of color in your minds what the kind of power that brings us by owning the boot volume as part of the how do you say, solution.
Martin, quick question for you, and it's from another Martin. What are the advantages for edge computing, if any?
That's a great question, Martin. And at GA, we'll be supporting a 4-node Nebulon pod. The entire management, operation, firmware upgrade, software upgrade, and so forth of the pods that we deployed are entirely driven, controlled by the control plane. So if you think about this in the context of, I'm trying to think of a use case, perhaps deploying a network function virtualization pod, giving you the ability to deploy that pod on a remote site, and then completely operate and manage the servers on that remote site from the cloud control plane. And what we'll show you when we get to the live demo is we will, by owning the boot volume and owning the controller and the boot sort of volume, around the build process of a pod, which we'll sort of come to sort of show you, we can change the personality of the server without any need to go back and touch the server physically. So a very good hands-off remote in the cloud management process.
Brilliant, thanks very much.
I was going to say we have a question from Chris Evans, but it looks like CMAX answered that already. So you can carry on, Martin. Thank you.
Okay. I can't see what the questions are, like the answers are,
No.
but I'll assume you're not talking about me.
That's the idea, is that I will ask the questions, but CMAC jumped in and responded on the chat. So you can keep going. Thank you.
Okay, perfect. Thank you. So we insert the card inside the server. If you don't mind, we'll hop ahead in a few slides and we'll see how we build the infrastructure that we're now in sort of control of. But having built the infrastructure that we're in control of, we're a lot more than a card inside a server. Once we're installed inside the server and a pod, which is a group of SPU-enabled Nebulon servers is built, we can then present local or shared storage sharing domains or data sharing domains inside the context of our pod. And we call that grouping an N pod. So the endpods themselves actually communicate with each other over a 1025 gigabit Ethernet network. So to the earlier point around, do you mean you really, or to the earlier question, do you really mean that you don't consume any server resources when you do what you do? We also don't consume any network bandwidth to do what we do. So the cards talk to each other over a 25 gigabit Ethernet network. So there's no need for any other protocols inside this, how would you say, solution. There's no ICE or SCSI, there's no fiber channel. The cards talk to themselves natively. And on this slide here, if you can see it on the view that like you have, the customer or the application data here is represented in sort of orange. And the important thing to note here is all customer data is kept inside the customer file or ball. What's coming out of the customer world is fully encrypted telemetry data in terms of what the system is sort of doing. So we can see in real time, and we will show you this when we get into the live sort of demo. We can see exactly what the cards are doing, exactly what the pods are doing, and provide and then provide some pretty clever and unique views around how those infrastructures are actually being sort of used and consumed in sort of real time. But in addition to data coming up and out, and us giving you and having the ability to read what's going on inside the data center, so many companies today have a cloud have a cloud control plane of some description in that they can see what is going on inside their data center. Not so many have the ability to then modify and change what is going on inside their data center from that sort of control sort of plane. So we
Martin,
also, yeah.
Sorry, I've got two quick questions that follow on. First of all, Chris Evans would like to know, are the cards running stateless, and are they writing data to media directly?
The answer is the cards actually have NVIDIAs in them. So they do have state that is stored in the NVIDIA that improves performance. So we don't write directly the data to the media, otherwise it will cause performance latency issues. So the cards have some state.
Okay, and Simon Bisson would like to know, how does this compare to the distributed storage backplane approach on OCPD's project Denali? Sorry, I cannot pronounce that. Controllerless SSDS.
The conversation with those, and there's a lot of cards that do NVMe over fabric acceleration, is none of them really provide the storage services that you need for enterprise. Things like snapshot, compression, deduplication, they all have the ability to get the data from here to there, but then they need some sort of a storage stack running someplace else. In our model, the storage stack essentially is imbued inside the card, and it provides all those rich services, including encryption, that is needed to run what a modern enterprise needs today.
Brilliant. And one last question, Martin, before we get back to you, is from Tony Locke. Is there a complete list of the telemetry data that you are taking and processing?
There's a number of information. We obviously take all the performance and capacity information from a storage perspective, but since we're a card sitting inside the server, we are actually able to query the server itself about its configuration, like the amount of memory it has, number of DIMMs, CPUs, all that information, the chassis, the type of chassis, serial number, all that stuff goes back to the cloud. And the card itself has an application agent that can talk to the application that is running inside the server. So remember, agents typically run on the server. In our case, the agent is actually running on the card. So it can query your Kubernetes instances, it can query your VMware instances, and all of that goes into the cloud. So you can actually have an end-to-end view of what you see from all the way from application all the way to the actual physical infrastructure that is running in your environment.
Great. And Martin, I've actually had another question come in, and this is actually for you. It's from Rob Hegler. So he says, PCIe Gen 3 or Gen 4 or both?
PCIe, that is.
Oh, PCIe.
Yeah, PCIe generation 3 or Gen 4 or both, Martin?
Gen 3, I believe is the correct answer.
Thank you.
And no one is contradicting you, so we'll take it as the right answer.
Yep, the boss didn't jump in, so I'm good with that as an answer.
Exactly, exactly. Carry on, Martin. Thank you.
Thank you. So to really kind of summarize this sort of slide back, telemetry information going up into the cloud, and also configuration information coming down from the cloud. Everything encrypted end to end. And I'll talk a little bit more around how we're doing some of that stuff in sort of later slides. But all of the telemetry information going up in read and configuration information coming down in write. So one thing to really be clear on with this SPU card is it's not an accelerator card. It's not trying to pull off the trick of making, you know, storage services go sort of faster by any kind of I'd say acceleration. It's a fully featured storage services offload card miniaturized onto a PCIe form factor. As I said before, with the insertion that we have being a SAS 8 BA, no software to install on the server or any of the the applications that might take advantage of what we're trying to do. So very simple to kind of go into your world. And we offload entirely with zero CPU impact to the host server. Data DG compression, erasure coding, so we use a read sort of Solomon algorithm to give a double disk sort of failure RAID. Data encryption, snapshots, data mirroring, all delivered from the card with zero impact to the server. So,
Martin,
yes.
Sorry, Mary Branscombe would like to know, are you basically an existing storage system but shrunk, or are you doing anything with computational storage inline?
We are a miniaturized storage controller, but that's kind of part of the story, right? The bit that really brings the miniaturized storage controller to life is the cloud control plane and what we've done there. And it's one thing to put many distributed devices into thousands of nodes. It's quite another thing to then go kind of manage them and operate them at any kind of sort of scale. So unless you fundamentally change the way that you do that, the approach is very difficult to be successful at. So we are a miniaturized storage controller, and we would never try to deny that like we weren't. But one of the secret sauce elements that we have is our ability to do distributed management at scale. And to think more around how, what's a good analogy here, how Tesla manages its cars. Tesla doesn't have a car go back to a garage to get the latest version of whatever Tesla's doing, or for the car to be sort of serviced. They distribute to their fleets of millions of cars out there in the field over Wi-Fi whilst your car is at home. We can manage and operate a fleet of these systems in exactly the same way. So yes, we're a storage controller, but there's a little bit more to it than that. And I have a whole section of this deck. We'll talk a little bit around how the cloud control plane works and what we do with it and how we make it secure and how we make it highly available. And then the demo, which is infinitely more interesting than the sort of PowerPoint, will give you a real view on how we see what we're doing and then drive what we're doing too. Okay. Okay, so the other thing that we can do by being this kind of miniaturized storage controller that lives inside the server is we can separate the fault domains and separate the servicing domains of that. So if you think about, and I have a slide that will talk about some of the more linear comparisons between what we're doing and maybe what an HCI solution is sort of doing. But one of the areas where you look at an SDS offering in any way, shape or form, they tend to be a piece of software running inside either a sort of container or inside some form of OS running on a hypervisor. And what that fundamentally means that if you want to service the hypervisor, you take the storage service down, because to implement one or to kind of service one, you have to impact the other. We completely separate the firstly the sort of storage service, or the CPU memory and so on to run the sort of storage service, but we also separate the impact of running one of those two things. So you are completely free to service the server that we live within, whether that be to update the OS or reboot the system, change the hypervisor, upgrade the hypervisor in a sort of some way, with zero impact to the storage service running on this card. And similarly, we can do any piece of servicing that you want on this card without impacting the server that we live within. So a lot of the advantage of a hyper-converged infrastructure, but without a lot of the downside of having to hyper-converge your operational model. The card sits right next to the processor, and it's on the PCIe sort of slot. So we drive very good performance and very low latencies in terms of what we can deliver. Into the applications that we host. Clearly, as we're not consuming any CPU resource from the server that we live inside, that gives you the ability to run the applications that you're intended to on the server when you bought it. It also obviously has a knock-on impact to software that you license per CPU core. So if you are thinking of Oracle or kind of VMware, where you have a CPU core license, in this world, you don't kind of pay a CPU performance tax to run a storage service that you end up paying for the software that runs the applications that you were trying to run in the first sort of place. As I said, we can group these cards together to form a data sharing pod or a data sharing domain. You can loop up to 32 of these cards together inside one pod. Each card can control up to 24 SSD drives, and at GA we expect to be supporting a 4 terabyte drive. So 32 times 24 times 4 with data deduplication, data in sort of encryption, pretty large petabyte scale shared storage domains, if that was what you wanted to build. But bringing the economics of server-based storage to that world, rather than the economics of array-based kind of storage and the price premium that you pay for those array-based approaches.
Martin, we have
Yes.
another question in. This one is from Chris Evans. He's asking, are the storage volumes / LUNs only exposed to the server running the card?
No, and I will get to that too, but no is the short answer. So we give a number of options, and if it'll be okay, I'll pause answering that until I get to a slide that really directly does address that, and a picture painting 1,000 words and sort of so forth. So I will get to that, Chris. The final thing that we're doing, which actually talks a little bit to Chris's point, is we're also workload aware, in that when you deploy a pod of Nebulon infrastructure, we build a template that is a recipe almost that defines what that service should look like. And I'll talk about it again in like a little bit more detail in the slide coming up. But if you think about all the basic primitives that you want to define as an application service, so what size are my LUNs? What's the snapshotting schedule that I want to run on those LUNs? What's the retention policy that I want to have? What kind of application is it? Therefore, what kind of data layout do I need to achieve high availability? Do I have a boot volume? If I have a boot volume, what's the operating system that I want to put into that boot sort of volume? All that information comes into what we call a template, which again is easy to think of as just like a recipe. And we'll do this live inside the demo, but quite simply take a bunch of servers that have got an SPU in them with no personality, you know, straight out the box, boot them up first sort of time. SPU talks to the Nebulon cloud. You pick the recipe that you want to play into that group of servers, play the recipe down, and we'll turn that into to a fully fledged service for you. So from 0 to MongoDB cluster, but from turning on the sort of servers and playing the recipe from the cloud down into what we're doing.
what does the a recipe specify, for example?
So it will. Can I park that one too? Sorry for parking stuff, but I will get to
Lot
it.
of parking going on.
Provided you don't forget, Martin.
No, there is
important.
a slide coming up that exactly answers that question. That exactly answers that for you. So I will get to that one. Yeah, okay. If that's okay, then I will get to that slide, and I'll get to Chris's slide too. So in terms of the use cases that we can go after, I tend to think of this slide as there are two use cases on the right, which are ones that folk have been doing for quite some time, and there are use cases on the left, which people are doing or beginning to do or trying to consider doing. And because of our insertion point in terms of the service that we can actually deliver, being a SaaS HBA that talks in a very basic way to the host server, we have a great fit for all of these use cases. We are not pinned to the virtualization use case because we're not pinned to having a hypervisor installed to make what we do work. So a very broad spectrum of things that have been done for quite some time and things that folk are moving towards. So this is the data layout question. So if you think about how applications work, from very traditional applications like, say, just a basic VMware cluster, VMware clusters tend to want to see shared storage and don't, from a VMware point of view, have any real way to sort of provide, from a VMware point of view, high availability to the applications that they host. So in that context over here, in the VMware production world, we have the ability to have a card installed in many servers, and the pod I'm going to build in the live demo is going to be one that looks like this. A pod of many servers. All of the storage inside each of the servers is hosted by an SPU, but appears to every server inside the pod. So we build a shared storage domain. So even though the SPU is inside the server, every server in the pod can participate in the storage. Indeed, the storage appears local to every card inside that pod. So shared mirrored might be a VMware production way of doing that, in that we not only have shared, but we also mirror the data inside the pod. So in the event of server failing or an SPU failing, we have a replica of that data inside the pod, and the SPUs inside the pod understand how to fail over and how to recover, and to see a max point. They don't need the cloud to understand how to do this, can all recover from any kind of failure event. It may be in a development world that you don't need the mirrored piece, so you can do without the overhead of having to mirror data. So we have the option to go for a shared mirrored view. But also, when you look towards the left-hand side, there are many applications and many use cases out there today that don't need mirroring and clustering to be highly available, because they're highly available in their own sense, in that they're cloud native. So if we think about MongoDB, or we think about a Kubernetes service, those technologies have the ability to build replicas of themselves and instantiate high availability by the fact of being that application. And in that case, we don't need to build a shared storage domain. We can run with a local per SPU version, and then that application pod is really being built when we talk about being application aware, that the application pod is aware of the application that it is running. So we can do that in a MongoDB friendly way, or even in a Kubernetes friendly way. So options around high availability, options around data layout, all of which are defined inside the recipe or the template that we build.
Martin, sorry, I'm going to ask a voice question. Sorry, I couldn't resist. I was just trying to understand that third model, the VMware development one, where you're drawing a diagram that shows cross connectivity between media in one device to another, and just trying to understand the data path there, because presumably both cards are in action. Both cards are involved in the I/O path, and therefore, as you scale that out from more than say 2 servers to say 32, you've got diminishing returns there because every server is involved in dealing with all of the data going back and forth between all of those clusters, if that was the model you were implementing. Am I understanding that correctly?
So from a data layout perspective, each card is a kind of primary owner of a volume as it's hosted locally, right? And then the cards communicate through the cluster to allow you to come in and access the data that is hosted by the card that is the kind of primary, if that makes sense.
So this is a bit like if I was looking at the way that, say, sorry, I'm going to use an obvious example like 3PAR was designed, where I'm in one node talking to storage that's owned by another node and vice versa, or if I was looking at the way that, say, DMX was originally built, I don't get access cross-device to the actual media directly because you're not exposing like the NVMe device across a network. You're actually having to do that translation for me through the cards, and effectively all the cards are involved.
Well, not all the cards are involved. It depends on a given.
Depending on the configuration, CMAC, yes.
Right, exactly.
Yeah.
But it bears kind of a little clarification here. When the I/O arrives at the card, even if the data is not hosted locally, that local device does the compression, does the encryption, does the hashing. So it does some of the compute, and then forwards the request to the actual owner. So it's a one-to-one translation. So if it arrives and it can be satisfied locally, it gets satisfied locally. If it cannot be satisfied locally, it does some pre-processing. Then it forwards it to the exact card that can do the actual full processing. So on a given transaction, at most two cards are involved. But if you have many LUNs and you're doing I/O to many LUNs, then many cards are involved, and that's the best way to break the performance among many cards and take full advantage of your entire environment.
Okay, does that not mean you need a broker in some respects? You need like a third party to manage when you get a split if you had a divided network or something like that?
You've got it. The split brain has to be handled, and we actually have a mechanism of handling the split brain. That's why initially we will support a three-system setup for shared storage. For non-shared, it doesn't matter because it's all local. You don't need a broker. For shared, you need to have 3 servers minimum initially. We will be adding support for 2 servers and use the cloud as the broker.
Okay, thanks.
Okay, thanks, Chris. Okay, moving on. So just a quick contrast and compare versus HCI. Not really we kind of get what HCI is about, and much of what it does is sort of great. We just wanted to be kind of clear around where we feel our approach is different. So firstly, obviously clearly with complete offload of storage services onto our card, there's zero impact in what we're doing in terms of the CPU inside the sort of server. And I think that we've seen, and I've been involved in my sort of previous life, the whole debate around what's HCI and what's disaggregated HCI and all the definitions in between. So we've seen some approaches to try to fix what is a sort of genuine constraint around that architecture. The other piece is very typically pretty much all HCI solutions VMware send a trick in terms of what you do. We don't suffer from that, so we can work in any hypervisor environment, and you can install a bare metal version of your OS on an SPU powered server node. We are server independent in terms of our fault domain. So when I talked a little bit around, the whole servicing and serviceability piece of what we do, having offloaded the storage service, it's not running in a VM. We can independently sort of service and have an independent fault domain. we have.
But Martin, this is a feature of the replication, is it, or does the SPU have its own power supply and carry on running even when the host server's not?
Yeah, so that's good. So the real interesting thing on servers is they, even in a reboot of a server, they keep power on in the PCIe slot. So we're drawing power, even though the server may reboot. The power that we draw is actually maintained through the PCIe slot.
Right. So as long as the server isn't actually sort of unplugged at the mains.
Yes. Yeah. We haven't solved that one.
Okay.
But but the rest of it, yeah. So it's and I didn't realize that that's how it worked, honestly, until I joined here. So yeah. So the fact that the PCIe slot actually maintains power even through a boot cycle in a sort of side a sort of server means that our card can also stay up during that sort of boot cycle. We have NVRAM on board on the card, so we don't need to install a write intensive SSD in like sort of side our server node to maintain performance. The software management is fully automated, and as is the SSD firmware. So we can update, and I'll talk about that in a slide coming up as well. But we can automate not just the software management of our card, we can automate the firmware management of our card, and indeed we can manage the firmware on the SSDs that we are controlling. And the other piece, which I kind of spoke about a bit before, is we're moving away from the context of managing arrays or managing clusters as infrastructure items. We're moving to a fleet management, scale, cloud-friendly way of trying to manage a very distributed in a sort of environment. So I'm now going to move into the control plane, and we'll see a little bit around what we're doing there. So the first thing to really kind of note is if you look at a traditional storage software stack, about 25% of that software stack is a very optimized small piece of software that's driven around the whole context of storage I/O. So writing data, reading data, data deduplication, data compression, data encryption, data replication, snapshots, all that I/O stuff is about 25% of the I/O of a software stack. 75% of it is management, reporting, and orchestration. Part of our architecture, and in reference to like an earlier point, we made the conscious decision to actually split that relationship. So we have a small, optimized, lightweight OS that runs on the Nebulon card, that runs on our Medusa card, that performs those storage I/O functions, and we have a management stack that performs all of the orchestration, management, and reporting of those functions. The interesting bit when you do that is you can deliver all the management and orchestration stuff as a service from a cloud. So a true SaaS model in terms of a lot of the kind of storage services or the orchestration of the storage services that like we have, which means you're always up to date with what we're doing, which means you can make use of new features as and when we sort of release them, much like we do today using Office 365. You know, there's a new thing that comes in our Office 365. We get to use it straight away without having to go and having to go and install a whole bunch more software on our laptops. The sort of final bit, the kind of 25% that lives on the card, and if you think about the relationship between the I/O bit and the management bit, a very simple piece is the ability to take a snapshot. So the ability to take a snapshot is a storage I/O thing, but the decisions around when to take that snapshot, how long to retain that snapshot, is that snapshot going to be is it going to be part of a consistency group, and how long am I going to retain it? That's a management thing. So the card has the engine to do the snapshotting and the management stack has the engine to tell the card what to do. And splitting those two things in apart, gives us the ability to introduce this SaaS model in terms of the software and how it runs, but also to give us the ability to run with this fleet management approach to the software inside the cards. The truth being, on the I/O stack, once you've got a hardened, ruggedized I/O stack, there's not often that you're going to change that. You can either compress or not. You may have a better compression algorithm coming out, but it's not something that will change that sort of frequently. But introducing new features around something like snapshotting is something that is a little more frequent in its sort of its nature. But we don't think that having to update the entire storage stack to take advantage of a new feature in snapshotting is a valid use of anyone's time. So we feel that running that small and optimized storage software package, if you like, on the card makes absolute sense. And then putting the management stack in the cloud makes absolute sense. But the cloud has the ability to manage the cards and manage the cards at scale. So we have the ability to update the software on the cards, update the firmware on the cards, update the firmware on the SSDs from the cloud. And because that data is being sucked into the cloud, we can run AI and look at how we can optimize the way data is laid out and the way that our system performs because we have this single point or this single view coming down into like our infrastructure. And I'm cognizant of time here too, so I need to press on if everyone is okay.
Well, before you press on, Martin, we have another question from Rob Pegler. Rob is asking, what processing resources are used on board the card? Is it CPU cores, GPU cores, FPGA, ASIC, etc.?
So we use an SoC technology on the cards. We have 8 SoC chips on each card, providing the storage services. And we also have a dedicated encryption chip that lives on the card too to do the data encryption services.
Mary is asking, so what cores are in the SoC?
They're ARM cores. There are 8 3 gigahertz ARM cores in the SoC.
Right. Any other questions? I mean, this is all going straight over my head, which is absolutely fine. But does anyone have any other questions? Would you like Martin to go back to something? Would you like Martin to clarify anything? Obviously, we're trying to establish a new category of cloud-defined storage here. I
have a slight question.
Thank you, Brian.
Given the some organizations are wary of would be wary of putting information like this into quote the cloud unquote. What plans have you got to enable a control plane on, for example, private clouds?
That's an interesting. Sorry, see, Matt, were you going to answer that?
No, go on, Martin, and I'll add some color to it.
Okay, so I better get this right, huh? But I think the interesting point to make there is that pretty much every enterprise technology out there today captures some form of telemetry data and stores it in a cloud. And the approach that we're taking is similar, but is by design. And on this slide here is actually more secure than the kind of I would say typical approach to doing that. So at this point in time, we are really working in terms of the data that we capture in a very common way, if that makes sense. But we're taking a very different view on it.
Yeah, the fact that everybody might be capturing telemetry data doesn't mean that all customers like the idea of vendors capturing their telemetry data. Trust me on this, but I'm talking to you from Germany.
Hi there, Tony. Yeah. Sia, Mac, did you have anything that you wanted to add?
Yeah, so I think you make a good point. There are customers that are uncomfortable about this, but at the end of the day, to deliver the best service, you need more of the data to make better decisions. A lot of that data will be fed to machine learning algorithm to learn from it and present the best data possible. To be clear, the way we are designing the data, and we understand some customers will never let the data out of the data center. And we actually had kind of a mix of customers in the past. Some 70–80% of customers were okay with the data, metadata leaving the data center. Some 20% of the customers were just said absolutely not, and nothing will leave the data center, including the metadata. So we designed our cloud services to be a series of Kubernetes instances, and we will look into the ability at some point to have the customers be able to have the management plane inside their data center. It's not in our immediate roadmap, and it will take some of the value away. I mean, a lot of the value is having the cloud be the control plane, is our ability to continuously maintain it, update it, and put the latest learnings into the cloud as soon as we have it available. Versus if it's sitting inside the data center, it just becomes a captive piece of software that has to be maintained, updated every few months, right? So it takes away some of the value from the model.
There are ways of managing that whole machine learning life cycle, though, totally anonymously using local cache, just sending back patterns, etc., rather than that metadata. So there are ways to skin that particular cat. It just adds obviously a bit more effort on your side, but it would make a lot of people much more comfortable.
Thanks.
Thank you. So clearly, moving to the cloud brings a whole bunch of other considerations, both around high availability and also security. So and I think we touched on it earlier. The Nebulon cloud is available in multiple availability zones of multiple hyperscaler clouds. In the event of a data center not accessing one of those hyper sort of scalar clouds, and if you think of the architecture we have around our cloud, it's more likely to be a localized event than it is to be something that in fact, I was talking to a service provider in Europe who was sort of saying that they, when they get into a denial of service attack, one of their standard protocols is they cut the line, so they can deal with the denial of service attack in-house. In that case, the card still needs to keep on doing what it's doing, and so the current running state of the card is like a constant, and it keeps doing what it's doing until it's told to do something else. It can recover from a component failure, or from a network failure, or from some other type of thing based on the logic that we've programmed the card with. So the cloud doesn't need to be there to take advantage of that. We offer role-based administration.
Sorry, Martin, we have one more question. It's from Martin. I don't know if there's a typo in the question, but Martin typed, looks like HP GreenLake in being an on-prem cloud element. Martin, I don't know if you'd like to jump in by voice.
It was a comment, not a question. It's just I'm intrigued because cloud is a kind of generic thing saying you user don't need to bother about anything, we're all sorted out like this. But I observed that GreenLake is an IaaS element that HP sticks in your data center, and you can switch it on and off as you want. But this is kind of interesting to me because this looks like, of course, the cloud service supplier could have these installed in its service, but it's sort of like a cloud, a thing that only makes sense through the cloud, which is installed in your own server. That was just a comment. I didn't mean to interrupt.
Okay. Thank you. Yeah, and GreenLake is, we're not quite there with HPE yet on the GreenLake side of things, but I can see how there's a kind of really strong parallel. Obviously, data is encrypted here, so it's encrypted in flight and at rest, and for all user interactions with our SPUs. So we really take the security side of things really sort of seriously. And the other thing that we do is we build what we call a security triangle, which is really a relationship between the user trying to do configuration or read information and our cloud and the SPU. And quite simply, what our cloud is working out is if the user browser is in the same firewall or is in the same network as the SPU, then it's okay for that user browser to be able to perform modification tasks on the SPU. If it's not, then clearly it's not. So the security model is analogous or no less secure, let's sort of say, than an on-premise appliance providing operations and management to a device that's being sort of managed. And we provide this security triangle federation as part of our security model. Now I'm rushing through some of this because I can see the time and I really want to get to the demo, because we really would be great to show you in sort of color, as it were, what it is we are doing. So very quickly running through this last slide, I believe. So global infrastructure insights, so we can capture all this information up to our cloud. I'll show you how our reporting can help you with the sort of decision making around that. We can, because we're collecting information at a single repository, a single point up there in the cloud, we can start to do clever stuff with that information around either predictive or preventative maintenance. And we can also talk to customers about in a very proactive way around how they might optimize what they're doing to give them a better outcome. We also obviously clearly provide zero-touch provisioning, everything driven via an API and a single API in the cloud. So even though we may be thousands of devices deployed inside someone's data center, the point of orchestration, point of management, point of all those things is a single API for people to go point stuff out, and we handle the kind of federation of that below.
Martin,
Yeah.
we have a question in from Anthony Adshead at Computer Weekly in the UK. How geographically distributed could an NPod be? Are NPod meant to be distributed at all, or restricted to single or near sites?
Single or near sites is the short answer to that question.
You're good at short answers, aren't you?
Yeah.
But there are opportunities after our first release to augment that with things like stretch clusters and the like, for sure.
Thank you, Craig.
Yeah.
We have another question. This time it's for Mary Branscombe, again in the UK. What can you predict the failure of? Presumably just your own hardware, not the cloud storage, as you don't have visibility of that.
So we can look at things like, so there's clearly we can see what the drives are doing. So we understand what the wear state is on the drive. So we can start to be more proactive and more predictive around how those drives are going to sort of fail. The hardware failure thing is a kind of very sort of, is a very basic view in terms of what we can see, but we can also start to see capacity trending and utilization. And because we're deploying things in the context of an application-aware deployment model, we can also see anomalies, or we can see best practices, if you like, in terms of the way that applications have been deployed, spot the difference between something that's working well and something that isn't, and gain insight from that, and actually provide customers with proactive insight into how they might improve that. And because our system isn't just reading information up, but it has the ability to write configuration down, we can also not only see what the problem, see what the opportunity is for optimization around the how to say service, but also give the customer the ability to optimize their service from our cloud. So if you changed A, B, and C to X, Y, and Z, you would get a better outcome. We can change the ABC to X, Y, and Z for you.
And Martin, are you also going to look at maybe doing a bit of modeling there, so that if somebody does have a particular workload and application that you've seen running in many locations and many instances, that you can automatically tell them, hey, look, here's a good starting point for your configuration, instead of you trying to work it out for yourselves?
Yes, so we see the templates, if you like, being a organic thing. So if you build a template for MongoDB inside your organization, it will probably be based on what we think, or we will give you what we think the right answer is. You have the opportunity to kind of modify that to better suit what you're doing. And then over time, we will learn whether that was the right answer or whether there was a better way of sort of doing it. We'll also give you the ability to model what an upgrade path might look like. So yes, I want to upgrade to the newest version of the software. What's the least impactful way of doing that? Or I want to upgrade marketing today rather than engineering. What's the impact of me as sort of doing that too?
Always upgrade engineering first, not marketing.
But yeah, I'm not going to make it. I'm in engineering, so I can't comment on that at all.
Martin, if you advance to the next slide, it'll kind of augment the answer you provided. And I think someone else wanted to get into what the template covers. So.
Yes, thank you. Yeah, so I was actually going to jump straight into the UI, but yeah, we are going to deliver the system with a bunch of predefined application templates based on what we've seen and the information we've had from our ISVs, which will give customers a great starting point to build services out on what we're doing. And again, we're taking a very application-centric view of how services are actually delivered. The bit I find interesting in this approach, talking to over the years, many IT departments, is they're kind of caught between this rock and a hard place in that they want to be able to give application owners the ability to provision applications and infrastructure on sort of premise with the simplicity that they can do it from the cloud. But the problem is the application owners, quite rightly, aren't infrastructure experts. So how do you kind of give the kind of controls to the application owners to deploy their own infrastructure, but do it within the guardrails of them not going way off piste in terms of what snapshotting looks like, or they forget to configure high availability, or they haven't put enough compute in, or there isn't enough storage there, or they made the wrong assumption on LUN sort of sizing. And all of those assumptions are very hard to reverse out of. So we figure by giving these templates, it gives the infrastructure teams a very simple way to deploy infrastructure, but it also gives them the option to put the templates in the hands of the application owners and give them a very cloud-like experience in terms of how they provision their own infrastructure. And know that MongoDB instance 1 is going to be the same as MongoDB instance 100 if you've used the MongoDB template to do that. So a very standardized way of getting things done. Yes, and thanks, Craig. This does talk to one of the points that we made for the type of things that we can actually talk about in the context of a template: number and size of volumes, data redundancy, data protection, snapshotting sort of story, how we want to share that data or not inside what we're doing, and do you want to install an operating system? Yes, no. And do you want us to put a boot volume in there for you? Yes, no. And we can constantly optimize that using system telemetry. So with that, I will get into the demo, if everyone's cool with that, and ask some questions as we go. So I'm gonna have to stop sharing to get this bit to work.
While you're doing that, Martin, can I ask the rest of the team a question on availability? And really the question is how you're going to manage failure. So imagine you lose a card and there's state and there's encryption keys and there's various other things on that card. The server gets pulled. Would you expect you'll replace all the drives on the card? Would you replace the card and put the drives back into that card and then power it up and expect to reflash that card with its previous logical personality? What's the sort of management of failure modes there?
So you described it perfectly in the second scenario. Essentially, if a card fails, you pull the card out, put a new card in. The card connects to the cloud and says, hey, I don't know what to do. I don't have any personality. What's going on? It records the drives that it sees and sends it to the cloud. The cloud will work out exactly that, this is a replacement card and it belongs to this pod. It needs to talk to these other members and other SPUs, delivers it as configuration, and off and running it is.
I was going to say, and presumably you're going to have your third-party server providers doing that, card delivery, etc., as part of their standard service conditions?
You've got it. So they just do the act of physically replacing the card through either their own service providers or directly themselves, or in the case of a customer replaceable unit, they ship a card, the customer replaces it, but once the card is in, they connect the Ethernet port, there is nothing to do, the recovery is completely automated.
So I'm going to log into the Nebulon on cloud, and I'm logging into as a super user, so I can see and do everything that's inside this cloud. But think of just logging in here as like a customer. What I'm going to see when I log in is the last screen that I went to. Let's click over here. So we're going to see an overview screen of all of the NPODs, all of the SPUs that are existent in this customer's infrastructure. So we have 3 departments here: marketing, engineering, and QA. And this, in the kind of spirit of openness, is our virtual POC environment that we've been running prospective customers through for the last 3 or 4 months. So this is real, live, kit, deployed. We've just repurposed it for this week. We're in the middle of the HPE Discover event. So we've done some stuff to make it look like one larger environment rather than like a customer POC environment. But what you can see here is three departments and all of the infrastructure inside those 3 departments. So we're not looking at a single card here. We're not looking at a single pod here. We're looking at an aggregated view of everything that's going on inside that department at this point in time, both in terms of throughput, in terms of latency, in terms of data efficiency, in terms of how much storage has been consumed, how much storage has been sort of zented. And just imagine for a moment the complex scripting requirement to just provide you with that view. If you didn't have this kind of Nebulon on view of the whole of the infrastructure beneath it. And if the overview is not of interest to you and you want to look at performance, we can click to a performance graph easily, with the same aggregation point being the NPOD groups, which are the departments where these pods live. We can also look at a capacity view and see where things are kind of going. So that's all kind of quite cool and interesting. If we wanted to move from an NPOD group, we can look at other primitives that we might want to group this thing by. So let's have a look at data centers. The pods are deployed in 2 data centers, one in Fremont and one in Belfast. And now I can take a view there, and I can see, moving from a department view, I can now move into a data center view and extrapolate that forward. I could move into a rack view, or I could move into an application view. What's even kind of more interesting perhaps is I can add an aggregation point now. So I'm looking at a per data center view. Well, I can add an aggregate here, and now I've got a Fremont view, a Belfast view, but I can see what the resources of the departments that are running inside those data centers are doing. So very powerful reporting, very powerful visualization of what's kind of going on. And I think about the CXO conversations that like we get into. One of the things that they want to know is, what's my VMware estate doing? Not what's my cluster in data center 4 doing. They want to understand holistically what VMware is doing across their estate. What's my Oracle estate doing? I've invested millions in MongoDB. Are we actually using it? So giving for free, if you like, out of the way that we can configure and report things, those views back into customers, we think is a really important piece. This is all driven via an API and a single API in the cloud. So if a customer wanted to use their own tools to go do this, then they absolutely can. And at GA, we'll be releasing a bunch of SDKs to allow people to both automate and report on our API. I can also just have a look at what my entire world is doing. So if I take the aggregation point of data centers off, I can aggregate all and see what my entire environment doing. And this is a collapsed view of all the things that, like you've seen before. I can also take a look at what an NPOD is doing. So these are the individual NPODs that make up those departments. And if I click onto this particular NPOD here, this one's running in a single SPU mode just to show a little bit more infrastructure out, but you can see the individual per sort of performance there. This NPOD has more than one SPU in it. In fact, it has 4. So I have 4 SPUs running. I can also start to look at things like actually comparing how 2 SPUs are performing versus each other. So do I, in the context of a pod, do I have an application running on a server that is pinning that server? Why am I having a problem there? It's a really interesting kind of diagnostic tools there too. But we're not just a reporting tool, right? So there's a lot more that we can do for customers in addition to the reporting side of things. And this comes to infrastructure management. So I'm going to move into the NPod management kind of view here now. And you can see here all of the NPods that we've had built. You can see the groups that they're in, and you can see the template that built them that delivers the service that they're sort of doing. From NPod management, we have things like snapshotting templates, which form part of the recipe. If we go into the templates themselves, I can go to this vSphere default template, and I can see exactly what the configuration items are, or what the config of that service is going to be. And I'm going to use this one, so kind of pay attention to this, perhaps. We can look at the OS that's going to be installed. We're going to give it some sort of metadata that allows us to identify what we're trying to do. If I wanted to, I could provision a boot volume here, and I'm not going to do that as part of this demo, but Andy's going to run in after me now, time allowing, and actually provision a boot volume, but do it in a very slightly different way to using the UI. We're going to do it through an API view. I can work out what the size of volumes are going to be, what my savings factor is going to be, and what is the storage style that I want to deploy. And do I have a snapshotting schedule? And if so, which one do I want to use? So very simple way to build the kind of recipe parameters for what this service is going to look like. I've also built a simple VMware environment here. So on the servers we're going to build, just in the interest of time, we've installed ESX on those servers on the M2 chip that lives inside the sort of server. But you can see when you look at what we've got going on here, the only thing the server can really see, there's no storage devices deployed in it other than that M2 chip. But you can see it's got a Nebulon HBA living inside it. And what I'm going to do is I'm going to build a VMware pod based on these 4 servers and deploy storage services into this VMware environment without having to touch the VMware environment. So back to NPod group. Okay, so let's go on to build an NPod. So we go on to NPods, new NPod. As I say, we're in the middle of HPE week. So all servers here for the build are all running on HPE hardware. I'm going to search here just for pod 1. So this is going to, I just have to know that they're all plugged into demo pod 1 in terms of the sort of switch. So I'm going to grab these 4 servers, and they're going to form my NPod. And you can imagine here, you might have hundreds of servers advertising back in terms of ready to build. I'm going to select a configuration template. And if you just look at the NPod preview piece here, when I select the configuration template for vSphere default, it works out based on the recipe what the infrastructure outcome is going to be if I deploy these 4 servers with their disk configuration with this template. So we can start to see what we're going to build. Out of deference to our host, I'm going to call the pod Fred, and I'm going to put it in the group marketing. And so I've got all the things that I need here. I've got some infrastructure, I've got a recipe, I've given it a name, and I've put it into a group, or I could create a new group at this point in time. I hit validate, and the sys then will now go off and make sure that everything that I've said can be done. So in answer, I think, to Brian's question around, can we distribute these pods across multiple sites at this point in time? No. But that is something we will do in like the future. But what we're sort of seeing now is making sure that everything that I've selected can be built. Validation comes back as succeeded, and I'll whack on create, and we're going to build an NPod. So we're going to provision storage services and present those storage services back into this pod. And you can see why we're not doing a boot volume here, because the whole process of writing the data to the boot volumes would have had us here until tea time. So I will jump through that. So you can see Fred's now built, and it's built of 4 sort of servers. And as CMAX said, we can see more information. We can see the serial number of the HPE server that we're sort of stored into. We can see what type of server it is. We can see the drives that we have and which slots those drives are in. We can see the volumes that have been provisioned. So to Chris's kind of question to sort of some point, each volume is owned by a sort of server, and we understand where the backup version of that volume is. And now if we flip into the VMware view, you can see that VMware now has all of that storage presented to it, and every drive or every LUN that we have presented is available to every server inside the end pod. Breathe out. And with that, I'd love to hand over to Andy, who is going to take us through a very slightly different view on doing a very similar task. So Andy.
Can I jump in and ask another question? This is from Chris Evans. He's saying, second question, have you thought of having serverless chassis running the cards as a shared storage platform?
So we have thought a bit the other way around, where we have a chassis that is running the customer application, but doesn't have any storage. It just has one of our cards. You can imagine a scenario where you have 10 servers, but you don't need the capacity in every single server, but you still need to be able to present the LUNs to that server. In that model, you could put the physical capacity in 8 of the servers. The other 2 just have a card, but they can still fully use shared storage that is presented to the entire pod of 10 nodes.
Right.
In the case of just using a chassis that doesn't run the application, that seems like a waste of resources to actually have a server that just has our card and has some CPU powers that are not running any of the customer applications.
Okay, can I just finish off, ask that first question? And that was really whether a snapshot.
Yes, yeah, that's a great question.
Can be moved around the infrastructure freely.
So the snapshot can be presented anywhere in the pod at GA. After the GA, we are adding iSCSI target support to the card, so that a snapshot can be presented via iSCSI to anywhere within the data center.
Okay, but for instance, I couldn't, for example, snapshot one server to another server and then use that snapshot as the boot volume to power up that server.
Oh yes, you can. So if you're talking about copying the boot LUN image essentially comes from someplace in the data center, and we'll just copy that, right?
Yeah.
We don't snapshot it because you don't want to depend, especially for boot LUN, you actually want to copy locally on that server, because if you get disconnected, you still want to be able to continue to boot the server.
Okay, because it's not independent, that snapshot's still linked to the original data.
Exactly. So it will have it will present availability issues.
Okay, thanks.
And presumably, applications running on that particular host machine would have local access, faster access to the data without it needing to traverse the network, or is the data too distributed and scattered for that?
I think you're correct. I think there will be a slight performance advantage if you access the data locally as opposed to hop on the network. Although, a top-of-rack switch hop is no more than 20-30 microseconds nowadays. Having said that, we are going to build a set of plugins for VMware, for instance, that teaches the affinity of the LUNs, so the VMs are brought up on the most favored host in terms of performance and access to the data locality.
Okay, thanks Martin, thanks CMAC. So what I'll do is take you through the last piece of the demo today. And what I'm going to do is really start with asking the question. So I have a server here running in the data center. And right now today, this is running vSphere, but it could be just running no OS at all. Could be a new rack of servers that we've put into the infrastructure that's there, and that we're ready to start this off, the process of bringing these servers into life, and how we could do that. Also how we can re-provision servers really quickly, and how we can do this with Nebulon and take advantage really of that. Also how we can do this with through APIs. So I'm going to show, I have the dubious pleasure of showing the API demo today. So some stuff that we've coded up that shows you how you can automate that entire journey that Martin's just done, and also add some new things into it as well. But with the huge advantage that there's just one endpoint for this, whilst there's lots of products out there today built entirely, with APIs right the way through. With this, not only have you just got an entire set of APIs, you've only got one place to go and call them with all the other telemetry the grouping and everything that we're recording there as well, which is really powerful and really simple. You know, my last company, SolidFire, we had an API-only platform, but you had to go and talk to lots of different endpoints to make these things happen. One of the great things I found with Nebulon in building out the demo center is you've got just one place to go and talk to and send your calls to. Okay, so rather than using the UI, we'll start with my demo. So we have a Python SDK that's available, and this is IPython using Jupyter workbooks and that SDK. And I'll run you through each of the steps that we're going to do. So the first 3 steps really are simply to log into the infrastructure, the username and password that we've got. The next thing we're going to do is then create one of these templates, one of these recipes automatically that's there. The difference with the one that Martin's created is we're going to create one that's 64 gig inside, but we're also going to copy down this CentOS bootline image here. And when we reboot that server, you'll see it come up and boot off that image that's there as well within that environment. So I'm going to create that template. We can now see within the infrastructure, the template has been fully created and is ready now to use for us to provision an endpod, the template there. So you can see the boot image URL, the boot image size. We're now going to create a group in this space and just showing you all the way along, no tricks up my sleeve here. So we have 3 groups right now. We're going to run that. We've created a new group that we can use in which to provision an endpod here. And then 7 endpods running right now. What we'll do next is create an endpod. So it takes a few seconds just for the work to happen that Martin talked about before. So, you know, we're provisioning and creating the LUNs and copying those out to the system. And it also then starts the process, once the LUNs have been created, of copying that boot image down. We're going to use a CentOS-based boot image today. It could be vSphere, could be anything. You could be running from a system that's got nothing running on it today. So we've created the endpod. You can see some output from the API script there and the UUIDs. I'm now just going to start another script here that gives me an amount of time. So I have the kind of, one of the worst bits of the demo is I've got a couple of minutes to wait. So I need to sort of talk about some other things while we're going through that. So it's going to take about 2.5 maybe minutes to copy down the boot image. And then we'll go back and boot the system, and you'll be able to see how that works and how we've automated that. So we have the now running endpod in this environment. We had 7, now up to 8 running endpods within the environment. And that's the one I've just created there. And again, you can see all of the information that's there with it. One of the other great things that we can do as well is update the system from the cloud. And as Martin said, you know, we've taken a lot of the reasons why you would have to upgrade a storage system sort of for the management domain out of it by running it from the cloud. So quite often we get deployments and new features and functions added into the cloud without having to update things on the underlying card. However, we can fully update the card as well automatically from the cloud. We can do that for subsets of the systems or for all of the systems at once. It also deals with the really thorny issue of updating the firmware on each of the drives within the environment, which is the firmware management on drives is something that's really interesting. And, you know, everyone's got their drive firmware horror stories. We can manage all of that process and the updating from that in the environment, but, you know, reducing the number of updates you have to do in the first place because the management domain is out there based in the cloud today. Other things we have within the environment, so you can set up different users and user groups, and we'll be increasing the amount of RBAC features and functions there as well. Then we've got a couple of alerts we've just generated here as well, just to show you what the alert system looks like in this kind of case. So let's just drop back here and just to see how much longer we've got. So what my script is doing here is just waiting to make sure that I've got LUN ID 0. So as the CentOS image is copied down to that local boot LUN on each system, as the LUN ID 0s start to get presented out there that we're going to boot from, that lets me know when I'm ready to reboot the system and ready to go. I'm going to manually reboot the system today, but nothing's stopping you doing this through something like Redfish APIs or for your standard ILO management tools to kind of automate the process. So just waiting the last few seconds for this to run down. So usually takes about 2.5 minutes, depending on the image. It does depend on the size of that. So the first one of those is ready. I'm actually impacting or installing boot LUNs onto every node in the pod here as well. So whilst we're only focusing on one server, all of the systems will be ready to run within that environment. So all the LUNs are ready. So I can come into my system, reset that device. So it's a fairly standard HP ProLine DL380 Gen 10 server here. You'll see the boot process start to go through. And in a couple of seconds, you'll see the sort of the actual evidence of the Nebulon card actually being inside the system from the boot environment. So you can see the card there, see how it lives and looks inside the system. And because we're operating as a local controller in the system, we're picking that up. And whilst this is all happening on-prem, data being sent back to the cloud about how this is happening and how it's being provisioned and controlled from within that environment. And so what was once a system that was here and running vSphere in this environment, we'll now see this come back and appear as a CentOS system running in this environment here as well. And so rather than provisioning a system, this, like I say, could be a whole rack of servers, could be across multiple data centers, something completely automated, could potentially be a way of taking one infrastructure that's run, say, vSphere during the day and Linux at night, running different environments. With this one here, now it's up and ready, we can then start to do things to it.
Andy, CentOS is like that, you know, you can get CentOS into a gigabyte, 3 gigabytes maybe. What's the other 60 odd gigabytes of your boot image doing? You've got a lot of stuff in there. What's there and what's it needed for?
So my actual boot image itself is on disk is 1.6 gig zipped up. That's just the size of LUN I'm creating to put that into to be my boot drive at that point.
Okay, thanks.
So that's spare space I've got to do that with. I also am presenting data LUNs as well to be able to store my apps into as well. So there's more to 2 sort of terabyte LUNs presented there in that space as well. Okay, so thanks for your time. That is my bit of the demo, the API demo all done there. Handing back over now to Fred, I think.
Thank you very much. So, well, that was a lot of technical information. I hope it made sense to most of you. I saw the questions coming in. Obviously, brand new company, we're going in a brand new direction. And I want to make sure that everyone understands exactly where in the industry we sit and where we are trying to position ourselves. Can I ask Craig maybe to quickly recap and explain in more, not layman's terms, but without the, you know, being too technical about that. Can you explain where in the industry we sit compared maybe to other players and other technologies?
So, sure. The I think the first thing that we recognize is the customers we talk to have an inordinate number of choices. And so the thing that we want to, you know, really kind of drive home is from a application owner perspective, the notion of self-service infrastructure on premises, it's not real achievable today. Those same individuals actually have that in the public cloud. And the public cloud, a lot of people talk about it being easy. There's a lot going on your AWS console, but an application owner can absolutely figure out what they need to get their application up and running. Most often on-prem, that individual needs to have his or her environment curated by an infrastructure manager. And that slows things down. There's not always equal understanding of what's required, etc. So the idea for what we're aiming to do here is to bring a sort of self-service capability, a storage operations as a service to the app owner who doesn't need to know what's going on with storage and to kind of get their job done. And what's in it for the infrastructure manager is if they're maintaining an infrastructure that now has a real self-service capability, they can do much, much more. I was reading the other day a study that suggested cloud-based management drives about a 4x productivity with those who are tasked with managing storage. So someone who might spend their entire day on storage might only need to spend a couple of hours with a cloud-based management approach. So, you know, the idea is take time off of the infrastructure manager, deliver kind of this immediate gratification to the application owner, and really focus on the needs of that individual on-prem, which, you know, to be honest, they're getting a fair degree of in the cloud today. So, you know, there's, I think that's our long game. And when we talk with CIOs, in fact, the CIO who sparked this whole idea in CMAC's mind, we were speaking with him just a couple of weeks ago. His whole vision for his infrastructure at the bank is an entirely self-service infrastructure. And from our perspective, it starts with storage. Storage is maybe harder than some of the other aspects. And if we can lick storage, maybe we can move on to some other things and really, you know, nail it for the whole infrastructure. That's kind of the you know, where we're trying to take this thing. I hope you can see a little bit of that in what we showed today. We're just at the beginning of this story.
I take it that your management API can also export that data that you showed right at the beginning there in terms of all of that management information, so that people can start to do more effective chargeback or blame back internally and things like that, and port it into their accounting systems.
Yeah, absolutely. Absolutely.
Craig, we have a question from David Norfolk. David is an analyst based here in the UK. David is saying, I've just read the press release quickly, and this seems to emphasize the need for on-premises data in some compliance use cases. I'm assuming that Nebulon is still worth buying, even if the data doesn't have to be on site.
We are, our customer, our goal is to address on-prem data, right? None of what we are doing today applies to data in the cloud. The metadata, of course, is in the cloud from a management perspective. But if you are entirely in the cloud, you are not a Nebulon customer today.